Hello everybody, welcome to my class. Today I am going to discuss about relation between V, R and W in circular motion. So here you can see V stands for the linear velocity, R stands for the radius of the circular path, and the W stands for angular velocity. So what is called this sort of thing have actually wide use in different problem solving area throughout mechanics. So here what you can give the topic is when circular motion. Alright, this topic is circular motion. Circular motion is means if anybody moves in a circular path, then motion of that body throughout this circular path is called the circular motion. So here let's suppose that this is the center of a circle. You can call this as O, and one particle is at position A and it is moving due this direction. Okay, so at this point with a speed V. So at this point, suppose that this is the this vector, this is the velocity vector, for example, then this vector will be the tangent on this circle at this point A. And from here, if you draw the line passing through the center, so this is called the radius, and by geometry you can you know that the tangent and the line through the circle or the radius is perpendicular to the tangential line. So here that means this angle will be 90 degree over here. A small time, say this is very small time delta t, the particle is at some position here, and you can call this position as position B. So its direction will be again tangent to this point. So this is the after time delta t, this is the another position of the object moving along this circular path. And if this is radius, this is again radius, and from geometry you know that this tangent and this line will be perpendicular to each other at this point B in this case. While changing the position from A to B, you suppose that the angle inscribed at the center is del theta in this case. So let's first come across the linear velocity. You know that linear velocity is change in displacement by change in time, or speed if it is, then you can call change in distance by change in time, or change in displacement per unit time for the velocity. And here this is also called the rate of change of displacement. And here with the angular velocity, angular means this is referred to some angle. So here you can say it refers to this angle, because while moving from position A to B, it has described angle delta t. So from between A and B there are a lot of points there might be. So from one point to another point, what is the change in the angle? So that we call it as delta t. So this is defined as del theta by in general d theta by dt. Okay, that means it is change in angle by change in time. Alright, that means we can call the rate of change of angle is defined as the angular velocity omega. And next, now let's move forward. So here you can see now from position A to B it has described this angle. And we also know that what we know, we know if this is a circle, for example, if this is a circle and this is center like this, and then if you have like that, so it is R and this length is called S, denoted by S. That is called the arc length. And if this is theta, then it is found that theta equals to S by R. That means S equals to R theta. Is that okay? Similarly, here we are talking about very small change in angle. Okay, this is the very small change in angle. So here in this case, if you use that sort of thing, what you can say here is like the same. What you can do here, from S equals to R theta, we have in R, S equal to R theta, let's take differentiation of this function both sides with respect to t. Then let's see what happens. So what we are doing here, we are taking delta t, delta S by delta t, and for any circle R is constants unless we make any change in the radius. So it is what you can write here, d theta by dt and r d theta, because R is constant here. So what you can say here, like R is outside, this is del theta by del t. Now let's apply the limit. So what you can say here, limit del t tends to 0, del S by del t equals to R del theta. Here also we have limit of del t tends to 0, del theta by del t, and here as R is constant, you can take this R outside. It's okay? Now let's see here in this case what happens here. We said that del theta tends to 0. So as there is t going towards 0, that means this del theta is also going towards 0. It's not in fact 0 but going towards 0. And hence what you see, if this length is del S, it also tends to 0. That means you see that point A and B are coincided to each other in case when the limit has reached. So here by definition of calculus, first principle, what you can write, this means you can write here ds by dt, and that is equal to, we have R here and this is d theta by dt. It's okay? So in this case now, what you can see, like we have now ds by dt. You can check here, like v is defined as ds by dt. So in place of ds by dt, what you can write here, v, and r is there, and d theta by dt, that is the rate of change of angle, is omega, that is the angular velocity. Therefore, in place of d theta by dt, what can you write here? Omega. Therefore, the relationship between v, r, omega is now established. Okay, so let's talk here. So unit for v is, you already know, the SI unit of v is meter per second, and r is measured in meter if you are using the SI system of unit, and omega, you can see this is ratio of theta and time. So theta for s equal to r theta, here theta is, or here in this case also del theta is measured in radian. So what you can say here, theta as the radian and time in the second. So also you can write here rad per second. So this way we see the relation between the linear velocity and the omega, that is angular velocity. So here in this case, if you want to say that the linear velocity, something like that, so in fact the motion is not linear in this case, so it will be more logical to say the speed, okay, throughout this circular path. But at some particular point the velocity has some particular direction. So if that wouldn't be the circular path, it will trace the straight line direction, and hence at each and every point you consider this as vector v, and hence we can say in very small gap the V is in fact linear.